I think one of the biggest misconceptions people have about AI, especially the large language models we use every day, is that they actually understand English.
Right. They don't.
They just understand math, probability.
That is the fundamental disconnect, isn't it?
Yeah.
We see this coherent sentence, and our brain immediately thinks comprehension. But the machine, it's just seeing a statistical likelihood that this word should follow that word.
But for that probability to be accurate, for the machine to sound, well, like a person and not a calculator, it needs a massive amount of evidence.
A staggering amount.
It has to see how language is actually used,
Yeah.
out in the wild. And that's where today's topic comes in. We're not talking about the algorithm so much today. We're talking about the fuel.
Corpus.
Or corpora, plural, yeah. We're doing a deep dive into Chapter 20 by Tony McHenry from Corpus Linguistics and its applications in NLP. And I have to say, this chapter totally changed how I look at things like ChatGPT or Google Translate.
It really grounds the technology, doesn't it?
It does. It's not magic code. It's all about the sampling frame.
It's a reminder that these systems are built on the back of decades, and I mean decades, of linguistic grunt work.
So let's start with the definition, because McHenry is very specific about this. A corpus isn't just, a folder full of text files you downloaded. He calls it a collection of attested language use.
And that phrase, attested language use, that's the weapon. That's the weapon corpus linguists use against the armchair linguists.
The Chomsky approach, right? The generative school.
Exactly. For a long, long time, the main way to do linguistics was just introspection. A linguist sits in an armchair, thinks up a sentence like, the invisible book slept furiously, and then decides if it's grammatically valid based on their own internal rulebook.
Which is fine for theory, I guess, but it's terrible for trying to train a computer. I mean, if I relied only on my own intuition about how English works,
Oh, it'd be a disaster.
I'd miss half the slang, all the regional dialects, and I'd completely ignore how people actually talk when they're, tired or in a hurry.
Precisely. Introspection gives you an idealized version of language. A corpus gives you the empirical truth. It's the difference between how you think you drive and the dash cam footage of how you actually drive.
Okay, so McHenry sets the stage. We need real data, but this is where I kind of got stuck at first. If a corpus is just real text, why isn't the entire internet just one big perfect corpus?
Because of the sampling frame. This is the science part. You can't just scrape the web randomly and call it a day. You'll get a biased result. McHenry's ticket sales example is, I think, brilliant for explaining this.
I loved that example. So, okay, let's say you're building a voice assistant for a train station.
Right.
You need it to understand people buying tickets. If you just feed it general English, say 1,000,000 words from Reddit and 1,000,000 words from Jane Austen.
It is going to fail. Spectacularly. Jane Austen isn't talking about off-peak return tickets to Manchester.
And Reddit users. Well, they might be, but probably with a layer of sarcasm or slang that you definitely don't want your ticket bot using.
Exactly. So you have to design the corpus. You have to think about balance and representativeness.
Right. So you need to record actual calls to ticket agents, but not just for train tickets. You'd need plane tickets, theater tickets.
They get the broader transactional vocabulary. And this is crucial. You can't just record one operator.
Oh, right. Because if that one person has, say, a lisp, or they always say Cheerio instead of goodbye.
The AI learns that as a hard rule. It thinks everyone in the world says Cheerio. You have to average out the idiosyncrasies. If you don't control that sampling frame, you're building bias in before you even write a single line of code.
It's so interesting because it implies that a perfect general corpus doesn't really exist. It's always designed for something.
It's a tool. It's not a mirror of the entire universe of language.
Speaking of tools, let's get into the different types, the typology, as McHenry puts it. There are the obvious ones, like monolingual, just one language, but then it gets into the cross-lingual stuff. Parallel and comparable corpora.
And this is where the definitions really, really matter. A parallel corpus is a text and it's direct translation. So think of a legal document in English and the exact same document translated into Spanish.
That seems like the gold standard for training a translation AI, right? You show it A, you show it B, it learns the connection.
It is the gold standard for machine alignment, yes. But for studying the languages themselves, it's actually a bit flawed.
Ah, because of what they call translationese.
Yes. When you translate, you're constrained by the source text. If I translate a French text into English, I might use sentence structures that are technically correct in English, but they feel a little French.
Like you're seeing English through a French filter.
Exactly. I might overuse a certain kind of clause or use formal pronouns where a native English speaker would just say you. So if you study that text to learn about English, you're not getting a pure sample.
Which is why we have comparable corpora.
Right. With comparable corpora, you don't use translations at all. You take, say, a stack of business news from the Wall Street Journal and a stack of business news from Le Monde in France. Same topic, same time frame, same genre, but both written originally in their native language.
That distinction is so subtle, but it's hugely important. One is for training a machine to translate. The other is for understanding how the languages naturally diverge.
And that kind of differentiation, it extends to spoken language, too. We mentioned recording ticket agents, but searching audio is a nightmare.
Yeah.
You can't just hit 2-F on a sound wave to find a word.
So you transcribe it. But McHenry makes the point that a simple transcript is a lossy format. You lose all the intonation, the pauses, the sarcasm.
Absolutely. The phrase, yeah, right, written down, looks like you agree with someone.
Spoken, it's a total dismissal.
That's the challenge.
Yeah.
So the solution, the technical solution, is time alignment.
Yeah.
You link the text to the transcript, millisecond by millisecond, to the audio file. It's incredibly expensive and time-consuming, but it's the only way to keep the prosody, the music of the language, while still making the data searchable.
There was one other category in there that I'd never heard of, the opportunistic corpus.
Ah, yes. The grab-what-you-can approach.
It sounds a little desperate.
It's pragmatic. I mean, sometimes you just don't have the time or the budget to build a perfectly balanced representative sampling frame. Maybe you need to analyze the language of a specific subculture, like right now.
So you just take whatever magazines or forum posts you can find.
Exactly. It's the good enough corpus. Or maybe the best we can do is zero budget corpus. And honestly, for much of history, that was the only option.
That is a perfect segue, the history of this. Because we take these massive data sets for granted now. We talk about billions of parameters in GPT-4 like it's nothing. But the struggle to just get volume started long before the computer.
A long, long shot. The hero of this story, or maybe the martyr, is a man named Kading.
The German researcher from 1897. The scale of what he attempted to do is eat. It's actually terrifying.
It is. He wanted to understand word frequency in German. But he had no hard drives, no processors, so he hired a workforce.
5,000 people.
5,000 analysts. They manually processed 11 million words of text, counting them, sorting them, all by hand.
I complain when I have to copy and paste a spreadsheet. Can you imagine the logistics, the paper cuts?
And the margin for error must have been huge. But it just shows the hunger for data-driven linguistics was there long before the tech was.
And then the computers finally arrive. We get BUSA in the 40s, and then the really famous one, the brown corpus, in the 60s.
Right.
Looking back, the brown corpus seems almost quaint. It was 1 million words.
A single Harry Potter book is about 200,000 words. So yeah, the whole brown corpus was basically 5 novels worth of data. But at the time, revolutionary. It proved you could tag and organize language on a computer.
And it set the standard for that sampling frame we talked about. They didn't just grab random books. They curated it to represent American English of 1961.
That curation is the key. But then the 80s and 90s hit, and things just exploded. The British National Corpus, the BNC, hit 100 million words. The Bank of English hit 300 million.
And now, of course, we've moved away from holding these on our own machines. It's all server-based processing. The data is just too big to fit on a laptop anymore.
Which leads us to the ultimate server.
The World Wide Web.
The web is corpus.
This is the modern battleground, isn't it? On one side, you have the optimists like Kilgariff who call the web a linguist's playground. It's free, it's practically infinite, and it's always updating.
And we have these amazing tools now like Bootcat, which is still the best name for a piece of software ever.
It is a great name.
You can just feed it seeds, say 10 very specific medical terms, and it will go out and scour the web to build you a specialized medical corpus in minutes.
That's incredible power, but then you have the skeptics. McHenry highlights this. Leach calls the web a dirty corpus.
Because of the noise. I mean, think about that sampling frame again. When you scrape text from the web, do you know who wrote it?
No idea.
Is it a native speaker? Is it a child? Is it a bot generating spam?
Or that genre confusion stat. That just blew my mind. Baroni and Bernardini found that if you search the web for a specific genre, 1 in 3 of your results won't be what you asked for.
Right. You search for fiction and you get a blog post about fiction or a book review. The metadata is a complete mess.
It's all casually prepared material, which brings us to the big why. Why do we put up with all this noise? Why do NLP engineers fight with these massive, messy data sets?
Because the alternative, the old rule-based approach,
Yeah.
it failed miserably.
This is the tag it versus clause showdown.
This is the definitive proof that data beats theory in this domain. So Taggart was a system used on the Brown corpus. It was rule-based. It had a long list of grammar rules to decide if a word was a noun or a verb, an adjective, and so on,
And its accuracy was 77%.
which means it was wrong almost a quarter of the time. In linguistics, 77% is basically useless. It's barely better than just guessing.
But why was it so bad? I mean, we have grammar rules. We all learned them in school.
Because human language is just incredibly fluid and ambiguous. The word run can be a verb. It can be a noun, like a run in your stocking, or an adjective, a rundown building. The rules for telling them apart are insanely complex and context-dependent. A human trying to write all those rules down will always miss something.
Okay, so then enter claw.
Clause didn't use human-written rules. It used probability derived from an annotated corpus. It looked at millions of examples and just calculated, okay, when the word run appears after the word the, it is 98% likely to be a noun.
And the accuracy jumped to 97%.
That 20% jump is everything. It's a difference between a broken toy and a working product. It proved that the hidden intuition of language, all the stuff we know but can't quite explain, it's buried in the statistics, not in the rule book.
And this brings us to the concept of the tree bank, which I think is so crucial for understanding how these companies actually build their products today. A tree bank is more than just a corpus. It's a corpus that humans have already graded.
It's like a massive answer key. In a tree bank, expert linguists have manually gone through and parsed every single sentence. They've diagrammed them, marked the subject, the object, the syntax trees, everything.
So it's a gold standard.
It's a test bed. If you're a developer at Google or OpenAI and you write some new algorithm for understanding English, you don't just release it and hope for the best. You run it against the tree bank. You compare your computer's answers to the human's answers.
It's quality control.
It's economic survival. Developing these models costs millions of dollars. The tree bank lets you fail cheap and fail early. It's the test bed that McHenry talks about. Without it, you're flying completely blind.
So to bring this all full circle, we started by saying that AI doesn't know English, it just knows stats. But those stats are only as good as the attested language we feed it.
Correct. And the symbiotic relationship is undeniable now. NLP needs the corpus to learn. But the corpora are getting so big, billions and billions of words, that linguists now need NLP tools just to analyze them. We can't use Kading's 5,000 manual laborers anymore.
So we're using the AI to study the data that trains the AI.
It's a complete feedback loop.
Which leaves me with a final thought to chew on. We talked about this big shift from the curated corpus, like the Brown corpus, which was so carefully balanced, to the web corpus, which is massive, but it's noisy and opportunistic.
The quantity over quality shift.
Exactly.
Yeah.
So if modern AI is just eating the web all that casually prepared, error-prone, unverified text, and we know that maybe 1 in 3 pages is misclassified or just spam, what does that imply for the future of these models?
It implies there might be a ceiling to how good they can get.
If we're prioritizing sheer volume over the balance and representativeness that those early linguists fought so hard for, are we just building a very powerful machine that specializes in, I don't know, casual, messy thinking?
And if the web starts filling up with more and more AI-generated content, the model eventually starts eating its own tail. It's just training on its own output. That is where the lack of a human-curated sampling frame might really come back to haunt us.
A lot to consider the next time you ask a chatbot to write an email for you. It's only as smart as the crowd it hangs out with. Thanks for listening to The Deep Dive.
It was a pleasure.